So anyway, we're just going over these example problems in lieu of a quiz. We aren't having a real quiz today. And so find your divisor. Then you're going to compute the standard quotas. So for example, 1,500 divided by 517 gives me 2.9. Whoops, can't write properly. Then 2,000 divided by 517, I got 3.87. 2,500 divided by 517 gives me 4.83. And then finally 9,000 divided by 517 is 17.4. Okay. So anyway, yeah, Hamilton's method, I think most of you have this one figured out, but I thought it'd be good to review nonetheless, is we find the standard quota and then everyone rounds down. So I'm rounding down here to 2. We round down. So 2, 3, 4, and 17. And then you reevaluate. You figure out how many you've actually apportioned. And it looks to me like we've only apportioned 26 seats in this House of Representatives. And so we need to apportion an extra 3. And those 3 go to the ones with the highest fractional part. So we're looking at these decimals here. And that'll be your answer. Oh, weird. Why did it do that? I don't know. Sometimes it does this to me. I don't know why. Okay, so far so good. At least we got that one out of the way. Webster's method, you're going to round in the normal way. And here, coincidentally, it ends up being the same as the standard quota. But normally you would have to guess and check and always guess, your divisor in order to round the normal way and create a situation where you have 29. But in this case, with the divisor equal to 517, you end up with these quotas: 2.9, 3.87, 4.83, and 17.4. And then round. So Webster's, you round the normal way. So this goes up to 3, this goes up to 4, this goes up to 5, this goes down to 17. And that worked. But had that not worked, that is to say, if when you got done with this, you found, oh, I only apportioned 28 seats, you would have to pick another divisor. All right, now let's take a look at Jefferson's method. So if we do D equals 517 with Jefferson's method, 2.9, 3.87, 4.83, and 17, bless you, 17.4. Sorry about that. For this method, you round down. So everyone gets rounded down. 2, 3, 4, and 17. Oops, there again. Doing something weird. There we go. So round down, and then you reevaluate. And if you haven't apportioned enough, so here the total is going to be 26. So I need to apportion more, so I try again. So I have D equals, say, 450. I know I've overshot, but I just want to illustrate what you're going to do for Jefferson's method. By the way, Jefferson's method, your starting point should always be the standard divisor, and then work your way from there. You're going to always end up going down. But let's see what happens when I use 450. I think I've gone way too far, but I just want to illustrate this, 3.3. So I'm just dividing the population, 2,000, by the divisor, 450. 4.4, 5.5, and then 9,000 divided by 450 is, oh, interesting, exactly 20. Okay, so now we're going to round everyone down. Everyone goes down, round down, and you get 3, 4, 5, 20, and that looks like I've apportioned too many. So there's 32 there. So here this was too few. So 517 was too large of a divisor. This one is too many, so this is too small of a divisor. So if this one actually had a solution, I would keep guessing and checking. Maybe try d equals 500 next. But apparently d equals 500 is the problem, isn't it? Is that all of these numbers are divisible by 500. And so you end up with 3, 4, 5, and 18. Is that right? When I do d equals 500. And so add those up, 27, 30. And I've apportioned too many. And if I were to increase, let's see, if I increase that any, like if I make it 501, then all of these numbers get a little bit smaller. So 501, d equals 501. This becomes 2.9, 3.9, 4, sorry. 4.9 and 17.9, and you end up with 2, 3, 4, and 17 again. So there's no way to win with this one because I picked a bad set of numbers. So yeah, Ethan pointed this out, that this d equals 500 is kind of like the tipping point. All 4 of these states. So the problem with this is that all 4 of them end up, when you decrease from 501 down to 500, all 4 of them end up gaining a seat. And so you go from 26 to 30. There's no way to get, how many do I want? 29? Yeah, there's no way to get 29 with this. So Jefferson's method fails. However, lest you think that Jefferson's method has something wrong with it, notice that I made up these numbers so that I thought it would make calculations easy for you. And in doing so, I actually made it impossible to solve. So that was, I guess, my fault there. Hopefully I didn't do, I'll have to double check the exam now to make sure that I didn't do that with the exam. So there it is. But anyway, if you were to do this, if this actually did work, you would keep narrowing down your divisor until you found one that worked. And by work, I mean when you round down, you get 29, not 26 or 20 or 30. All right, so I want to make sure that you understand this because, like I said, the quiz that I gave, I guess I have to come collect a few of your quizzes because some of you aren't here. I'll get those in a bit. So on the quiz, I noticed that several people got this like totally wrong. So I wanted to make sure that it makes sense. Webster's method, you're just going to round the normal way. You might have to make a slight adjustment, but because you're rounding the normal way, usually it's going to work out the first time or the second time. That one's not bad. And then, of course, Hamilton is different from all of the rest. So any questions about that? I know I made a mistake with the last one, but it is what it is. Yeah, Jack?
So you just, for the Jefferson's method, didn't you just do the same thing where you just appoint, or would that just turn it into the Hamilton method if you just appointed the seats right to the 26 to the, what is it called, the highest decimal or whatever?
Yeah, that is Hamilton's method.
So it just completely transformed.
Yeah, so yeah, if you did that, you would get Hamilton's method. So yeah, so Jefferson's method, generally you'll give you a different apportionment than Hamilton does. Let me see, what about the practice test? Give me a sec. So this is the next thing that we're going to do is, once I find it, is this it? Oh, yeah. So this is old exam problems. Yeah, so for this one, So we don't have to do this completely now, and I encourage you not to copy these down. This is available online. Um, by the way, here, let me show you this so that you know. I was in my second class, or not my second class, my third class, statistics. So I was in statistics, and I had a student. I was talking before class to one of the students, and that student said to me something about the test. And I said, well, just look over the practice test. And he said, you have a practice test? I mean, that means that he didn't realize there was one for the first exam. So I kind of laughed at that point. But I just want to make sure everyone knows that if you look online, there is a practice test. It's like exam problems from old exams. I don't have my answers up there yet. Why don't I have my answers up there? I'll put them up right now. Um, so I apologize. I should have had those up there. Let me see if I can find them. Give me a sec. What is this? Math systems? Intro to math systems. Okay. Oh, interesting. I don't have them. Okay. Hold on a sec. Just a minute. I'm going to have to change this around. Quick share. Oh, crud. Well, it's been uploaded. Um, okay, this will just take another sec here for me to copy this over. Where are they? Just a minute. Here we go. Okay. Let's see, turn editing on. Okay, but by the way, I guess I wanted to point out that there are these old exam problems that I just got from other, like various old exams. And now there's the alleged answers to the old exam problems. And the only reason I say they're alleged answers is because I might have made a mistake. When I was, writing up some of these answers, I do this, I'm distracted playing, Mario Kart or something while I'm trying to do this exam. Uh, so, uh, but let's get down here. Here's what I wanted to show you, is that when you're doing Jefferson's method, usually it takes a little bit of work, and you'll eventually get something that works. And so I didn't show all of the work that I did for this Jefferson's method because it was a lot of work, and I didn't want to write it all down here at least. But I tried the divisor 900, which I think was the standard divisor, rounded down, and I got 8. I think I'm supposed to apportion 9. So then because this was too few, I reduced the divisor to 850, rounded down, and I still got 8 for my total. And then I tried these divisors. I actually tried them. I was using my spreadsheet though, my cheater method. But anyway, I tried the divisor d equals 800. Then I tried d equals 750. Then I tried d equals 700. And then when I got to 700, I know I tried a bunch of them. Uh, um, I ended up apportioning too many. Then I tried d equals 725, and I apportioned too few. Finally, I got that Goldilocks number right there in the middle of 710. So 710 worked for me. And so when I did 710, I had these quotas. I rounded them down, and I got that for my final answer. So it's pretty rare for Hamilton's method and Jefferson's method to be the same answer. In this case, they aren't. You'll notice that in Hamilton's method, on this, and if you haven't done it yet, you don't write. Well, you could write it down if you want, but I encourage you to try it yourself. I got 2223 as my final answer, and for Jefferson's method, I got 1224. So different apportionments for different methods. This one, the practice test, ended up being the same um, the same as Hamilton. And anyway, so I didn't have to hunt around much, but just be aware you might have to do some more work than this quiz and this test and what you've been. So on the actual test, you might have to hunt around a bit. Okay, so there's Webster's. Just want to make sure that we did this because, like I said, there was some confusion, I think, for some of you on the quiz that I gave back to you. So are there any questions about any of this? Hamilton, Jefferson, Webster. All right, so someone asked about the definitions. So there was one of you was particularly, let's see, let me get a blank version of this. Just a sec. Yes, hold on. And then this is test 2, practice questions. Nope, that's statistics. You don't want that. Okay, so it's going to take a sec to find this. Test 2, old exam problems. There we go. Yeah, I just wanted a blank one so that we could look at this. So let's go down here to the ones, the words, just the definitions, so that we make sure we get it all. Is this what you were asking about? This one? Yeah. Okay, so let's take a look at this. We'll talk through this and make sure that you know what's what. So first things first, you'll notice that, let's see, this is not organized very well, but I will highlight, how about in yellow, I will highlight all of the ones that have to do with voting. So there's that one, and then these 3. I should have had them grouped together. I think when I edited this to make your exam, I did group them together because I thought that would make it easier for you. So those 4 are all voting methods. So I'm going to just put some highlighting up here, and I'll write down voting. So those 4 are the voting things. And then the other 4 are for apportionment. So we'll do that as well, maybe in pink. So there's that. And then these 3. Those, oh, sorry, I didn't highlight the bottom one. There we go. Okay, so the pink are all apportionment. Okay, kind of fell off the edge of the page there, but you got it. So I guess just to, on the actual test, I've got them grouped so that a little bit easier to keep track of. So I guess the reason I wanted to point that out is that if we're talking about an election, you're going to do the voting method. These are criteria that are either violated or not. And then when we get to apportionment things, we're going to do the pink there. So that's the first thing that may help you. I have slightly different scenarios that I describe on the actual test, but it's generally the same ideas. So you should be in good shape. So let's see if we can talk through this. For the first one, candidate A is the winner of the election, even though candidate B would beat each other candidate in an election involving just 2 candidates. Okay, so think about what that means for this one, because you had a quiz like this a little while back, and I remember people had a little bit of trouble with that quiz. It was like 3 weeks ago. It was right after your last exam. Anyway, if candidate B would beat each other candidate in an election involving just 2 candidates, what that means is that B is the head-to-head winner. So B would be the head-to-head winner. Like if B went up against everyone else in Mario Kart or whatever it is, B would dominate, and yet B doesn't win the election. And so that doesn't seem right, does it? Well, that's a violation of what's called the head-to-head criterion right there. So that's letter B. I know this is pretty straightforward, but let's make sure that we got it so that you can do this. You'll have something similar on the actual exam. So the actual exam, similar situation. multiple choice, but or matching, but like I said, I kind of grouped them a little bit more logically instead of having it interspersed. Next one, candidate A is the winner of the election. Once again, voting. So we're only looking at the yellow things. So candidate A is the winner of the election, but loses to candidate B after a third candidate drops out of the race. That is the situation where someone who is a loser drops out and it changes the election. So this loser shouldn't, the loser, it should be irrelevant whether the loser is in the election or not. But in this case, the loser actually caused someone to win or lose based on whether they were in the election. That's called the irrelevant alternatives criterion. Irrelevant alternatives just says that if you have an election and one of the losers drops out, it shouldn't change the election. Okay, next one. Candidate A is the winner, but loses after several voters move candidate A up in their preferences. So that one, I guess I could mark these off as I use them. That one might be the hardest one to identify. Whichever one is hardest for you, you can always skip it until the end and come back to it. But this one, what that's referring to is that if I get more people to vote for me, I shouldn't start losing the election. So if I'm the winner and I get more people to vote for me, I should still win. That's the monotonicity. Monotonicity just refers to this idea that we're going up and we're never going to go, like if you have something that's monotonic, it just means that it's going the same direction, either up or down, and it's always going that direction. So if you increase your voters that support you, you should also increase in terms of your final, election results. And then I guess that leaves majority. Majority is the easiest, I think, because it says it right here. B has a majority of the votes and A wins the election. So that's no good, right? All right, now let's go on to the apportionment things. These four. This first one is it's the Alabama paradox. That may be your hardest one to deal with. I don't know. But the others are so easy that you could always just leave that blank until the end and then be like, oh yeah, that's Alabama. So the next one, if an apportionment gives state A 4 seats and B 10 seats, and then the state A is increased by 1,000 people and state C is increased by 800 people, state A now gets just 3 seats and state B gets 11 seats. So how in the world does that happen? Well, it does happen every now and then. However, we don't like it to happen. And so this is a situation where the population is increasing. I know the word population doesn't actually say that. It's not stated here, but population goes up, and yet the state's apportionment goes down. And so that's called the population paradox. So that's C. The next one's also pretty easy. Once you see that you're adding a state, notice that you've got state A and B, and then state W is added with the appropriate number of seats. And then it turns out that A and B change in their apportionments a little bit. That's the new states paradox. Seems like a new state shouldn't affect your answer. And then, of course, the last one is going to be the quota rule. But in case you didn't, you could always it's talking about quotas. 2 seats is less than. So the quota rule says that this state should either get 4 or 5 seats, because rounding up you get 5, rounding down you get 4, but they only got 2. So that's a quota rule violation. All right, so let me pause there, make sure that makes sense. If there's questions about that one, I'm happy to do my best to answer them. So does that look all right? So there's a similar thing on the actual test. It's different wording, different scenarios, but it's the same ideas, different order. But it'll be fine. You'll do great. Okay, now let's do this one. So Hill Huntington is not on your exam, just so you know. We decided to skip that one, even though it's super cool. It's the one that is the most mathematical, and the rounding. All four of these are divisor methods, meaning that you guess and check the divisor until you get it to work. Adam's method is the one where you round up. Let's see, we never actually did any of the problems with Adam's method. There's another method that we skipped over as well that we aren't even going to mention. But Adam's method we skipped, but it rounds up. Let's see, Jefferson's method rounds down, which is B, and Webster's method rounds in the normal way. So that's pretty much it. So there's the words. Guess you can read pretty well. All right. Any concerns, questions about this one? Any of these? Looks okay? So anyway, other than that, I can show you what the exam looks like, but I'll show you that in a minute. You'll notice that there's only two other things on it. You've got this voting stuff. Oh, I also threw an approval voting method one on it. I thought you'd be fine with that because everyone was really excited about the approval voting. Yeah. Okay, so the approval, I know that some of you were. Approval voting was super easy, hopefully. So I just threw one of those on. It should be pretty straightforward. And then there is a voting situation like this. So, and then of course the stuff we've already talked about, these things. So what else do we need to deal with, if anything, from this? Yeah, what do you think, Nick? Yeah.
Is the border account the same as the pairwise?
No, board account is different from pairwise. Thanks for bringing this up because, yeah, I don't have board account on the practice test, but it might be on the actual test. So let's just double check that you know what board account is and the difference between pairwise comparison. So first off, pairwise comparison, which is listed here. Pairwise comparison, I think they might have called this the Copeland method. But anyway, pairwise comparison, what you do is you have a pair A versus B, A versus C, A versus D. This is the round robin tournament. B versus everyone goes up against everyone else. B versus D and C versus D. Once you have those, in this case, six head-to-head matches, you go back to your original preference schedule and you ask who would win. I'm just going to do one of these. I mean, I could do them all, but they're on the answer key. So I don't know that I need to do any more than just one. Let's just do B versus C, just to illustrate how this works. So for B versus C, I'm going to ask, okay, who does everyone vote for when you're doing B versus C? And you can see that all of these people are going to vote for B. Those people will vote for C. That one person will vote for B. So notice that you're going to vote for whichever one is more or higher up in your preference schedule or your preference ballot. And so for B versus C, B gets, let's see, 12 plus 10 plus 3 plus 2 plus 1. That's how many votes B gets. Give me a sec here. This is 6, 8, 28, I think. Did I do my math right? 28. I'm going to go with it. And C, on the other hand, gets 7 votes. So in that case, B is the winner of that little mini election. But of course, for pairwise comparison, you have to do this for every possible pairing. And some of them will be ties. And if you have a tie, then that's like half of a win for each person. And as far as the score goes, or whatever we're calling this, the number of points, you'll just add up the number of times that the person has won, but you get half of a win for a tie. So if you did have a tie, you would get half of a win for each person. So anyway, that's pairwise comparison. Let me jog your memory about board account. The board account is the one where you have different point values for the different places. So like this, let me erase this mess here. Give me a sec. There it goes. So you would have 4 points, 3 points, 2 points, and 1 point. And then each candidate would get that many points for each of their voters. So for example, A is going to get 12 voters. Each of them gives A 4 points. So that's going to be 12 times 4. And then these 10 voters, that's going to be 10 times 4 points each. Those 3 voters, 3 times 1, because each of those 3 voters gives A just 1 point. And then 2 voters give A 2 points. And then you have 7 voters giving A 1 point and 1 voter with 1 point. Anyway, I would add that up and do the same thing for B and C and D, and whoever has the largest, the highest score would win. That's the board account. So that's the difference with pairwise comparison. You're literally comparing pairs of candidates. Board account, on the other hand, you're doing this weird point value thing for the place that everyone is in the thing, the preference schedule. All right, what else do we need? Other questions, concerns? All right, there was someone here, I forget who, claiming that they had to leave early. And so I wanted to make sure that you all knew that I'm going to be in this room giving exams starting at 7:30 on Friday. So you want to come early? Come on early. And I'll have your exam here. I'll have the whole stack, but yours in particular, come on early if you want to do it early. I have an exam right before this class in here, so you can come as early as 12:30. So I'll be in this room from 7:30 to chapel. I will not be in this room during chapel because Tavares Taylor is preaching, and he's amazing. And then after chapel, I'm going to go have lunch. And then from 12:30 to whenever you guys finish, which probably won't be too long because this is an easy test again, I'll be here. So you can come as early as 12:30. But if you come at 2:10, which is when we're supposed to start, it's okay. If you come at 2:10, though, just be aware everyone will be here and they'll all be started. It's not that you're late. It's everyone else is early. You'll be okay. Okay, so I think that's it. If you do want to stick around and chat, please do so. I'm going to stop the recording in case you have some secret thing to tell me about.